Hello everyone, and this is another recording for dynamic memory pointers. Now, the previous recording did not record the audio, so now I'll just have to do it again. So, what is dynamic memory? Question is, do you think the game is loading everything? In RPG games like Zelda or other huge worlds, like maybe Elden Ring or God of War, right? Do you think it loads everything right away? So most games won't fit in your RAM. Compare the install size and your RAM. So why are we talking about RAM and not the storage? So games access your RAM because it is way much faster to access all this data than of course than your storage. So what they do is they store values and properties in the RAM. Right. So games cheat by loading only what is needed. Now, what you see with your camera, that is what usually the game loads. So depending on the game developer, it would it could either load everything right away or they could load only the things that can be seen in the map in the camera. So the game developers would rather choose the latter because it saves much more RAM. It doesn't lag the computer or the console because we're only using what is needed. So if you don't see it in the screen, it should not be loaded. So in the early era of mobile games, RAM is very limited. So one texture alone is already 1 megabyte or more. So what dynamic memory does is it allows us to allocate and deallocate memory at runtime. So when you allocate, you create new memory, you store data into the RAM. And when you deallocate it, you free up the memory or you remove that stored data or whatever out of the RAM. So we do this so that we don't max out our limit in the RAM. So if you only have 8 gigabytes, we try to limit our memory to way less than 8 gigabytes. Or else your computer starts slowing down or maybe even um, blue screen of death maybe. Or it'll just crash the program or crash your computer. So it does that. So in games where there are loading screens, the previous map is unloaded from RAM and the new map will be loaded in. So you don't that's why you usually have loading screens. If not, we have a way to deallocate or to remove the map when going to different stages. For example, in God of War, remember if you've played this game, you would sometimes go through tight spaces. So you see Kratos just moving slowly through the hole. And what the game is doing here is it is actually deloading the previous stage and starts to load the next stage. So that's how they try to save memory. In other cases, of course, you have the loading screen. So that's the most direct way so that uh, it will deload and load the new map through the loading screen. That way, the player doesn't see what is happening, what is being loaded, what is being unloaded, etc. So most games don't load textures immediately until the player is close enough to the object. With slower machines, it's easier to notice this. So actually, what happens here is we sometimes have our artists create different textures. You have textures when high detail textures when we want the player to is near, and we have really low detail textures when the player is far, so that when they see the map or the item from afar, it kind of looks like the item, but it it actually isn't. We save quite a lot of space from this because remember we have also like 4K textures or maybe 2K textures. So what it does is we try to lower it. We maybe use a just 64 megabytes of texture instead of the whole 4K texture, right? So that's one way. That's why this happens. It's still trying to load this new uh, detail texture. So next we'll talk about stack and heap. So stack's memory is static. It is already determined at compile time, while heap's memory is dynamic. This is determined at runtime. So for stack memory, this is what we have right away in the program. Like if you have like a int a is equal to 5 or int b is equal to 6. So this is stack memory. It is already here. It's already uh the value is already here, the data is already here, right even before the compile time. However, heap memory is dynamic. This is determined at runtime, which means it is new memory that is being added. So um what we have here, well, you learn this later. We have something called like, let me just create a struct here, a simple struct. So you have something, oops, let me just semicolon. You have something called new, which is like, is it C is equal to new. So this is dynamic, right? It is being created on at runtime because we can have multiple of these. Maybe in the function you'll create, maybe if you want 5 or 10 times of this, you'll do that. Unlike here, it is already static. So we'll talk about this more later. So using dynamic memory. So the problem with native arrays is that we can't actually give a dynamic amount for the array. We can only give a number, a size beforehand or during compile time. So user input can only be evaluated during runtime. So one way to solve this is through std vectors. With std vector, we're able to create dynamic. We can pop or push back in the vector during runtime. So how can you make an array dynamic without using vectors? To do that, we have to go through allocation. So to allocate dynamic memory, we use the new operator followed by the data type. So in this case, you have float pointer or the asterisk dynamic float is equal to new float. So we should have the same data type. You cannot have int and asterisk and dynamic float is equal to new float. That won't work. So it should have the same data type. So new memory is stored in the heap, which is again during the runtime, which can be managed in runtime. Yeah. So we didn't set up a reference to any variable. The object it's pointing to is directly in the heap. Okay. So this is what it looks like. So we can access the value also using asterisk dynamic float. So allocation with arrays. Since allocation is dynamic, we can wait for user's input before we create the array. So dynamic array must be stored in a pointer. The output of the new operator can only be stored in a pointer. So it must be. You need to have it as a pointer. You can't put it in anywhere else. So accessing the element of the array is the same. So we can use the index operator for ease of use. So we can simply just use this. So it's almost the same thing. It's just that with the pointer, we can actually have a dynamic amount of uh, of size in the array. And we can populate the same way. So this is another important thing, the allocation. So delete operator deallocates an allocated memory. For every new operator, for every time we use new, there must be a delete operator. So each time you create a new, there has to be a delete. If you do not delete, you'll have a problem later on. So we'll talk about that. So for arrays, we use the delete and then the open and close bracket to delete all the elements of the array. So without the brackets, only the first index will be deleted. So why only the first index? So remember, a pointer is pointing to a same thing. It's an address in the heap, the address of the heap memory. So if you only delete, if you just use just delete and then the name of the pointer, you only be taking the very first one. With the delete and the open and close bracket, it will delete all the memories within that was used for that uh, dynamic array. So very important. So again, why? Why again? Well, why do we need to have always a delete when we have a new? It's because of memory leak. So memory lives and dies at a fast rate in most applications. Once we're done with any data, we have to deallocate it. So remember, our memory, our RAM is finite. It is not infinite. It is only limited to the size of our RAM. So it should only be reserved for data that we're currently using. So again, for every new, there must be a delete. So if you just keep on creating new, eventually your memory will be maxed out and then you'll again either reach a blue screen, maybe your computer crashes, maybe the program just crashes. It really depends. So you must have a delete for every new operator. So memory is as big as what your RAM allows. So here, putting the delete open close bracket float array at the end of memory leak fixes the leak. So in here we have float asterisk float array is equal to new float 100. So it dynamically created space for this array of 100 floats. What you see here, we have a for int I is equal to 0, I less than 500, and then memory leaker. You see here that there's no delete happening. So if you try to call this, it creates 500 times 100 is 500, 5,000, 50,000. It created 50,000 slots open for this new floats. And the thing is, we never deleted it. And what if you have multiple power of this? You're gonna be using so much memory and none of it is being deleted. So this is a solution but doesn't explain the cause of the leak. Memory leak happens if you don't deallocate the before all the pointer reference pointing to the same object goes out of scope. So what do you mean out of scope? So if you have something in a in a function, if you have this float array, you created this in a function. What do you mean go out of scope is what happens if the code is running already outside. It's running outside of memory leak. In this case, it will go to the next line, which is here. It's out of scope already. We have no way to actually delete this outside of here because we don't have any reference of where the address is. That is why it should be done within the scope, within where the um, new operand operator is used. Now, Sure, you could have maybe a global variable, right? It really depends. Maybe you have a global variable. Sure, that could you could still have access to the the variable. It is not out of scope anymore. But if it's here, there's a we must delete within the function. So memory code happens with dynamic memory. Master of memory management requires a mastery of variable scoping, meaning you must know when to delete it, when and where to delete it. So tips. Value type objects are stack, which is are yung just the int or double, whatever, without the a pointers, right? They're immediately lost. They're immediately lost once they go out of scope. So like if you have a function here, like a void, this function, we have int c is equal to 2 and p is equal to 5, right? That's the function. So if we run to this, so it goes here, goes here, goes here, goes to test function. This is created right away in compile time, but outside of it, the moment you go outside of this, the memory that was used here is gone. This is not used anymore. It's out of scope. So they are immediately deleted. So all declared variables, community pointers are stored in the stack. So content of reference variables can be either in the stack or heap. So same thing. If you have a int asterisk pointer, PC, or int pd, these are in the stack. And same thing, if you go out of scope, this memory or this pointer, they are lost right after going out of this function. So you're okay with this. You don't have to delete anything here because the program does it for you. However, memory management requires awareness of when an object should be deallocated. So allocate objects at the latest time possible. So if you have to play a sound, only allocate it when you're about to play it. You don't have to immediately create all the all the memory at the start if you're not even going to use it at the start, right? Maybe you only need to use it for one function. So don't immediately create it right away. Try to do it at the latest time possible, whenever you need it. And same thing, when you want to deallocate objects, you do it at the earliest time possible. So if you're done using a pointer, you don't need it anymore, go ahead and delete it. Go ahead and deallocate it right away. So the owner of the allocated object is the one responsible to delete it. In this case, if it's within this function, they own these pointers, so they should also be responsible in deleting it. Just try to keep that in mind. And later on, you'll learn about classes, and then that's where you have to delete it within the class. So you learn about it in the future. So a function returns an allocated object is not the owner of the object. Its ownership is transferred to the caller. What does this mean? If you have maybe a pointer, a return type of a pointer like in get int, right? You have a return new int, maybe I don't know, right? Whoever uses this, maybe inside inside the main is now responsible in deleting the memory. So it is not the responsibility anymore of the function, but responsibility of whoever called it. In this case, main. So main should be responsible in deleting, in deallocating the memory of the pointer. So when to use a pointer? A pointer is just a reference with an added memory management feature. So if you only need referencing, just use a reference. What does this mean? Now, if you just simply need to, let's say, get a value, or you need a you need to update a value, if you can simply do it with a reference, then go ahead and do reference. Like, what if we want to just get a value within? So maybe we can just use const int ampersand val, right? We don't have to immediately use a pointer, right? It's not required always. It really depends on the use case. So if you're just simply just going to get a value, a the data, sure, you can just use ampersand. Or if you need to update it, sure, you can just use ampersand again. But if you need to, if it's a bit more complex, like you have a array, a pointer leading to an array, sure, you can now use the pointer. So it really depends. Depends on your use case. So if you need dynamic memory, use a pointer. So accessing an object in a heap is a bit more expensive, right? That's why we the right reason why it's more expensive, because you're trying to access things in the RAM. Well, instead, all of the stack memory, all the ones that are created before compile time, they're easily accessible because they already have mm, addresses for set for it, and it's not created in runtime, right? So it is more expensive to access a heap, the one in the runtime. So at this point, we will rarely need dynamic memory. Once you have an application object comes and go, it will become more common. So right now, we don't really need it. Later on, when you start learning about OOP or object-oriented programming, where you have classes, that is where we will extensively use dynamic memory. But in our case right now, it is not used that much. So, should I use pointers for vector? The short answer is no. Why? Remember, vector is already dynamic. It is already, you're able to add more objects to it. It has a dynamic size, right? So it's already dynamic on its own. So you don't need to. You only use reference or the ampersand for vectors if you need to pass it around, because they're easier to use and does the job. Just remember, ampersand memory. You don't have, if you, without the ampersand, you're actually creating a new vector pa. That's why we try to use ampersand most of the time. So vectors do not need to be dynamically allocated, as it is already dynamic under the hood. So vectors can already accept dynamically allocated elements by using pointer data types. So not only does it you not only can you just use a normal int, you can also have pointers within the vector. But remember, since vector is now holding these pointers, wherever this is should also handle the allocation. Not just because you go out of scope for the vector doesn't mean it will automatically delete these pointers. So it still have to be allocated by yourself. Should I set a pointer to null after deleting? Yes, you should. Why? If you dereference an already deleted address, the program will throw an exception. We call this phenomenon zombie. So what does this mean? If you, let's say, here, this new int, right? So let's say a is equal to 5. Oops. Asterisk a is equal to 5. So if you count here, of course, std count, it'll show up 5. But if you delete it, and we try to print it again, there are a few things that can happen. It will still print out 5, or maybe it will shoot out an error. Depends, right? That's why it's a zombie. Sometimes it works, sometimes it doesn't. And we don't want that to happen. That's why a good practice is we use null after deleting. So this is a good practice because this way we don't accidentally do this, right? We don't accidentally do this because sure, this may work when you try it out, but maybe later on in the future it doesn't work, and you're gonna be scratching your head, why isn't it working anymore? Because again, it's quite finicky when you deallocate it. When you deallocate, we simply just free up the memory, but doesn't mean that we actually deleted the value. That's 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 the reasoning. Okay, so try to, or always make it a good practice to null out a variable after deleting it. Right. So programs will assume that the object is alive if it's not null. Especially if you try to work with another programmer, you see that it's still available to use. But apparently, you already deleted it. That's why, again, try to make it null. If a pointer is going to be out of scope anyway, you don't need to set it to null pointer. Meaning, if maybe you did this in here, within test function, technically you don't need to have null here anymore since it's already out of scope. You don't need to access it anymore. Okay? Because again, you have no access to anything within this scope since it's just within here. Unless again you have a global variable. Yeah. So that is dynamic memory. So again, let's put this developer. Phase std. So again, if you create a new and is equal to new int, you can put values in it by using point asterisk a, right? So you can do that. So for every new, in case you're not going to use it anymore, let's say we calc a here. If you're not going to use it anymore, make it a good habit to delete a, so you have no memory leak. Not only delete it, if you're still within the scope, right? Meaning, let's say we're in main, it's still within the scope. Make it a habit to null it, so that we don't accidentally use a right after deleting it. So that's 1. 2, if you have a array, so let's say we have a test here, right? We have an array of test, b is equal to new test. So we can access this again with let's say p0 is equal to a is equal to 5, or b1 a is equal to 6. So we can access these like that. And remember, if you're going to delete an array, it has to be delete, open and close parentheses, then the name of the variable. Again, good practice is to set the pointer to null. Well, if you're within, let's say you're within here, you have like test c is equal to new test, and then let's say we did something here, and then we delete c. We don't have to do c is equal to null anymore because you're already at the end of the function, so we don't need to null it out anymore. It'll automatically just get rid of c. Okay. What else? Oh yeah. With again, because of dynamic memory and pointers, we can have a res- a dynamic amount of elements in an array. So let's say we create array of in size. And then of course we can also make this ampersand const. We can go like test d is equal to new test and then size. And then we can have like a for int I is equal to 0, I is less than size, I plus plus. And we can do things with the with the array. So let's say di dot a is equal to maybe rand percent 101. Then if you try to see out this or int I is equal to 0, I is less than size, I plus plus, we can again access it with the open close brackets. Let's end that here. And, create array, let's say 5. Right, so we have all of these. So this one, you notice it is address because we only said 8. Also, again, I created a new here. I should have a delete as well. Since we're out of scope, I mean, we don't need it anymore. We use delete bracket. And there you have it. If you do asterisk here, there, we have 5. Okay, so that's how you use pointers. This is how you allocate and deallocate variables. So again, make sure each time you have a new, you should have a delete somewhere. All right, for like in this case, if you have something like here, int f is equal to get int, since again, since we're transferring the responsibility from this to main now should be responsible to deleting the or to deallocating the memory. All right, so yes, this is the dynamic memories with pointers. Again, just message if you have any questions.